Thanks for stopping by for yet another fun-filled, action-packed episode of Vintage Audio Review. In this episode, I'm going to talk about this Fisher X101D Integrated Amplifier. The 101D version was sold between 1965 and 1966 for around $200. It was rated at 27 watts, both channels driven, although a load was not specified, at not more than 0.5% THD, and had a frequency response of 20 Hz to 20 kHz plus or minus 1 dB. The original model X101 started around 1955 from what I can tell, and it progressed into different models, ultimately to the 101D version, which we have here. Now this belongs to an audiophile I know, we'll just call him Michael, and he asked me if I would like this to be a subject of a video, and I said, you bet. So that is kind of how I got it. It is not my own personal one. We'll see how it performs in a little while, but I kind of wanted to give a little tour about it. I do want to point out that all the tubes are branded Fisher tubes. I don't know if they're the original tubes from 1966, but they all say Fisher on them. It uses 4 7591 tubes for the output and 6 12 AX7 tubes for the preamplifier stage. This thing is in great shape. If 10 were the highest mint brand new out of the box, I would probably give this one about a 9.5. It is just in really pristine condition, and we'll take a tour of it inside and outside, and then talk about the performance, and I'll tell you what my impressions were listening to it. Here is a more close-up view of the X101D Integrated Amplifier, or as Fisher calls it, a control amplifier. We'll start off over here on the left. We have a headphone jack, we have an equalization for either tape or phono, we have our speakers on off, high filter, a tape monitor switch, and the loudness contour. On the right side, here's our on-off volume control. We have a balance control, and you'll see where I have it pointed is kind of what gave me the best balance between the two channels. We also have a treble control and a bass control. The channels are separated within the ring here, so you could hold the bottom part of the ring and turn it for the left channel, or vice versa for the right channel. We have our mode switch here, which gives you your mono, stereo, or reverses the left and right channels. And then we have our selector, which has a tape play position, auxiliary tuner, phono, and a tape head position as well. This obviously is the rear of the X101D, and it has a little bit different arrangement for the inputs. The A or left channel inputs are down here, and then the right channel or B inputs are along here. We have our tape head input, then we have 2 phonos, high and low, which would probably be for a ceramic cartridge or a moving magnet cartridge. And then we have our tuner input and the corresponding one down here, auxiliary input, and then you have the tape play and recorder output inputs. As far as the speakers, you have connections for 16 ohms, 8 ohms, and 4 ohms, and then the common terminal there, and for the left channel it is the same way. There is also something a little unusual in that there is a center channel output, which when I looked at the schematic, the headphones and the center channel are connected across the commons. I'm not sure exactly the purpose of that, probably to give some kind of an ambience, an additional ambience to the stereo playback. It does have 2 unswitched AC outlets here, and I think we can just see these 2 jacks are for going to a reverb for each channel. So it's not a pre-out main in, it's actually designed to go into a reverb and is earlier in the circuit than would be your normal pre-out main in jack. And you can see your output tubes here and output transformers, power transformer, etc., etc. The X101D has 3 adjustments that can be gotten at pretty easily, and they are for the right and left phase inverter, those 2 guys, and the bias adjustment, that guy right there. The one thing I found interesting was that they specified that the unit be hooked up to 4 ohm loads And once that was done, I adjusted them. The bias was off maybe a volt from what was specified, and the left and right phase inverters required a little bit of tweaking, not a lot, in order to get the minimum amount of distortion that I could. And I made my measurements after having those adjustments done. Here is a view of the X101D with the bottom cover removed, and it kind of just shows you the technology that was used at the time and how clean this unit is. Here we have the THD SNR plot at 1 kHz for the Fisher X101D Integrated Amplifier, and I just kind of wanted to show what it looked like just to start off with. You can kind of tell that the left channel has a real low SNR in the 40 dB range, where the right channel is 60. The right channel has maybe 0.7%, and the left channel is varying around, and you can kind of see the left channel in yellow. Let me get rid of the right channel. He's kind of moving around a bit, and we're putting out 5 watts into 8 ohms here, and we both got about 16 dB, so the channels are very well balanced. However, the left channel just is not looking good. So this is kind of a starting point for looking at this amp, and I'm going to do some tube swapping and a few other things to see if I can improve the left channel's performance. Here we have the THD SNR plot at 1 kHz with the X101D putting out about 5¼ watts into 8 ohms. And this is with a 0 dBV input. And this follows my removing all the tubes and testing them. I didn't find any bad ones, and cleaning the front panel pots as well as the switches. So things are looking pretty good. The volume control is set at about 6, which is maybe 1 o'clock, and the balance control is adjusted so that the right channel is favored at about the 1 position. So overall, this looks fairly decent. Here is the frequency response of the X101D with it putting out 5¼ watts into 8 ohms with a 0 dBV signal applied to the auxiliary input. It's basically showing a +1 dB to a -3 dB response at the ends of the frequency band, depending on which channel. The right channel looks to be a bit better at the high end of the frequency band, but this is just what it is. I'm sure there's probably some adjustments that could be made with the tone controls. I wasn't able to find any requirements for the frequency response, but I'm sure it was supposedly better than -3 dB at the high end of the band. Right now I am going to switch in the loudness contour switch, and we'll see what effect that has on the frequency response. It looks like it boosts the bass up anywhere from 1 to 5 dB depending on where you're looking at, and it leaves everything else pretty much unchanged once you get to about 100 or 200 hertz. This plot here just shows the harmonic levels with the X101D putting out 8 watts into 8 ohms, and I'm just showing the left channel. This would be the fundamental over here, and the second harmonic, so this would be an even harmonic, so it's higher in level than the third harmonic, which would be an odd harmonic, and then we have the fourth harmonic, which is even, is higher than the fifth harmonic, and we have the sixth harmonic is higher than the seventh harmonic by a little bit, which is even. So it looks like, at least for the left channel, the even harmonics are higher in level than the odd harmonics. If we go over to the right channel, we don't really see that. Here's our third harmonic, here's our second harmonic right here. It's lower than the third harmonic. Here's the fourth harmonic, which is even, which is lower than the fifth harmonic. So it kind of just depends on which channel we're looking at as far as the harmonic levels. Right now we're looking at the frequency response of the X101D from 20 Hz to 20 kHz, with it putting out about 5 watts into 8 ohms. And what I'm going to do now is flip on the high filter and let's see what effect it has. Looks like the switch isn't making as good a contact for the right channel, but the left channel is being attenuated rather sharply, starting at about 4 kilohertz. If I flip the switch around a little bit, the right channel came in and stayed. So even though I had cleaned the switch, apparently it still has a few little issues. Here we have the multi-tone response of the X101D, and it's basically between minus 50 and maybe minus, I don't know, 60 dB down. So it's basically got a distortion-free range of, we'll be nice and call it 10 bits. Here we have the THD SNR plot at 1 kilohertz with the X101D putting out about 5 watts into 4 ohms with a 0 dBV signal applied to the auxiliary input. I should point out that the bias control has been set, as well as the phase inverter adjustments for both the right and left channels. The THD is pretty close to the 0.5% spec level, although this is only at 5 watts, and the SNRs are better than 76 dB. Here we have the frequency response of the X101D with it putting out about a half watt into 4 ohm loads, and it does look better than when it's putting out 5 watts into 8 ohm loads. The high end of the band is down anywhere from minus 1 to minus 2 dB, and the low end of the band is, at worst case, we'll call it 1 dB. And the channels seem fairly well balanced at this point, and I did have to use the balance control to get them to both track one another. Right now we're looking at the noise level of the X101D. In this case, the auxiliary input is terminated, but it is connected to shorts, and we do have 4 ohm loads on each of the speakers, and the volume control is set for about a position of 6. Now, right now I'm just showing the left channel. If I click on this over here, able to get a marker, and at 60 hertz, which is our power supply hum, we're down about minus 67 dB. Now, if I bring in the right channel, let me get rid of the left channel, you can see the right channel is down minus 80 dBV down. So the left channel definitely is noisier than the right channel. Right now we're looking at the THD SNR plot at 1 kilohertz with the X101D looking into 4 ohm loads with a 0 dBV signal applied to the auxiliary input. And what I'm going to do is increase the volume until I hit 1% THD. That is going to be what I consider the maximum output power for the Fisher integrated amplifier. Now, the only spec I could find for the maximum output power was 27 watts at 0.5% THD or less, and that isn't specified into whether or not the 101D is looking into an 8 ohm load or 4 ohm load. We'll try it both ways and see how much power we get into that respective load. And since I could not get less than 0.7% THD on the right channel, I'm just going to say that when we hit 1% THD, that will tell us the maximum power that we're going to be able to get out of this thing. So I'm slowly going to increase it. Now we're at 10 watts, and the left channel is got a little bit more power than the right channel, but we're still less than 1% THD on the right channel. We're at 12, 13 watts. We're getting pretty close to 0.9%. There we go. Probably right there. We'll call that it. So at about 16.8 watts into 4 ohms, we have hit our 1% mark. Now, if I went ahead and just get rid of the left channel, you can just see the right channel by itself there. And here is just the left channel by itself there. This is a plot of the crosstalk between the left and right channels. In this case, a signal is applied to the auxiliary input left channel, and the auxiliary input right channel is terminated into a short. And so you're looking at the amount of leakage from the left channel to the right channel. There is no specification for that, but I thought it would be interesting to look at. You can tell over on the high end of the band, we are down maybe 30 dB. It gets down to maybe 55 dB at 1 kilohertz, and then around the 100 hertz, 200 hertz, it's better than 60 dB. We do have an incursion of our 60 hertz noise spike right here, and then it settles up around 50 dB at 20 hertz. So that kind of just shows the isolation between the left and right channels. This is a plot of the output impedance of the X101D. It's basically less than 1 ohm for probably up to about maybe 3K, and then it starts getting worse up to maybe, we'll just say 3 ohms. That would translate to a damping factor of 10 to as low as maybe 2.5 for this particular unit. There is no specification for it, but I thought I would just put it out for. Oh, this is good to know. Here we have the multi-tone response for the X101D with it looking into 8 ohm loads, and there really isn't much difference between the level of performance into either a 4 ohm load or an 8 ohm load. It has somewhere between 9 and 10 bits of distortion-free range. Here we have the THD SNR plot at 1 kilohertz with the X101D putting out about 1 watts into 4 ohms, and I thought this would be a good place to start because 1 watt would be a lot of power into an efficient loudspeaker system, which you should be using with an integrated amplifier like the 101D. You can see the SNR is in the 70 dB range and the THD is under 1%. We'll just call it that. The THD plus noise is greater than minus 40 dB. So that's kind of where we're at. And this is with a 0 dBV input signal into the auxiliary input. And the tone controls are set flat. I did have to adjust the balance control to favor the right channel so that it was positioned around the 1 position, and the volume control is at about the 4 3/4 position, I guess I would call it. You can see that the right channel in red has these harmonics that are greater, and that is why its THD plus noise is worse. You can see that the hum over here, this guy right here for the left channel, is greater than the right channel by probably 20 dB. And that kind of makes sense from when I listened to it. I did hear a bit of hum with the volume set to a minimum coming out of the left channel, but nothing out of the right channel. For my listening test, I connected the X101D to my Klipsch La Scala loudspeakers. And the source I use is little Surfans F20 music player. It will play .dss, FLACs, wave files. And I use that running into the auxiliary input to run through the gamut of music that I normally listen to. Now, there was a hum out of the left side that was louder than the right side, and you kind of saw that in the data. That's the 60 hertz hum. It really wasn't that loud once you were a few feet away from the speakers, but you definitely could hear it. And the right side, I couldn't hardly hear it out of the right side, but it was there a little bit. Once you play music, it was just fine. I was able to attain SPLs of 84 to 88 dB without really much of a problem. When I started playing louder, which would put this probably in the 10 watt, 9-10 watt area, the distortion level rose and I backed down a little bit. But other than that, for most of the listening, it did a nice job. I did like the loudness contour on where that bass was boosted. I thought that did a nice job. I think this sounded just fine for the most part, as long as I kept the distortion from rising, and honestly, at the levels where the distortion rose with the La Scalas, it was really loud. That was in the 88 dB SPL area, and you're not normally going to listen to it that loud. At least I am not normally going to listen that loud, but for just normal listening, it did a fine job, and it would be a nice integrated amplifier to have in your collection. I should point out that I didn't bother to test the phono stage on this unit. I didn't think that with the frequency response that I saw just going through the auxiliary input, I didn't think that the phono stage would look that good, and just decided not to test it. It didn't make a lot of difference to this integrated amplifier whether you were hooked up to a 4 or 8 ohm load. It has taps for both of them. Other than that, I thought it did a decent job. It's just a beautiful looking piece of vintage gear, and I appreciate Michael letting me borrow it to test. Once again, I thank you for watching. If you have not subscribed, that would be very nice. And if you like the video and you click like, that also would be a nice help for making this channel grow. And once again, until next time, have a great day or night.